14 students. Okay. So let us start slowly. So module 1 is about solar radiation. So solar radiation, everybody know what is solar radiation. It is not a new item, but we will talk something technically about it. Okay. That means what is its constituents, components, how to measure it, what is the variation occurring in solar radiation availability on Earth at various seasons. So all these things are the subject matter. So sun is there, right? Is there anybody who don't know solar radiation or sun? I think everybody know sun, right? Yes or no? There is no response. No response means I will think that you don't know what about sun. Siddhartha Soni.
Yes, sir.
Have you seen sun?
Yes, sir.
Okay, how it look like?
Practically, it look like that they were saying about this.
Practically it look like?
In the image, saying about this, what sun look like.
Whether it is looking like the figure shown here, some arrows are there. Is it
This
look like that?
no. This is a
Uh,
radiation. That's
so basically, what is the sun? What is happening in the sun? It's a dense gaseous globe, right? The helium, hydrogen, all these things are present mainly in the gaseous dense globe, and we have the fusion reaction happening, and that is why it is radiating, right? Energy radiation means energy only, electromagnetic radiation. So you and I also emit radiation because we have a greater temperature than absolute zero. But our radiation is very less compared to solar radiation. Why? Because our temperature is 30 degrees Celsius. But what is the temperature of sun? Any idea? Surface temperature 5800 Kelvin, right? So our temperature is 30 degrees Celsius means plus 273, 303, right? 303 Kelvin. So 303 and 5800 you compare. Which one is greater?
Suns.
Suns, obviously. Okay, very good. So that is why it is having so much radiation compared to other items. Even moon also may emit radiation, but we don't use moon radiation. At night we may have a visibility in if there is moon, right? We are not producing solar panel energy using moon, right? We always talk about solar radiation because it is high compared to others. And other facts you can see here. What is the distance between sun and earth? Average we can talk because it will vary over the seasons. So it is 1.5 into 10 raised to 8 kilometer, very large, right? Otherwise 93 million miles. So it takes light energy to travel 8.31 minutes to get into earth from the sun's surface. What is the speed of light?
3 into 10 to the power of 8 meters per second.
That means 3 lakh. 3 into 10 raised to 8. 1 lakh is equal to 10 raised to 5. No. So how much lakh meter per second?
3,000, I guess.
Okay, 3000 is very large meter per second. Okay. So at that speed, it takes almost 9 minutes to travel between Sun and Earth. Okay. So these are all the facts about Sun and Earth. So you can compare. Sun diameter is 8,65,000 miles. That means 1, 2, 3, 4, 5, 6, 7. 1 crore 39,000. Sorry, 13 crore 92,000 kilometer. That means over 109 times Earth. Gravity is 274 meter per second square. For Earth, it is 9.81. You know that. So as mass increases, gravity also increases. Gravitational constant, right? So like radiation, each of us radiate, but doesn't matter. Each of us also attract. Gravitational constant is there. No, for us also we can calculate. All objects with mass also attract as per Newton's law, but our attraction, gravitational attraction, is not significant compared to that of Earth. That is why we are attached to Earth. We can walk, all things are there. We don't move and stick it to another object because that force is significantly less. So like that, radiation, all the energy ultimately come from Earth. Other energy transfer between objects are insignificant. Radiation and energy transfer. Okay, that is what I am telling. So solar radiation is electromagnetic radiation ranging from about 0.25 to 4.5 micrometer in wavelength, including the near ultraviolet, visible light, and near infrared radiation. So this thing, what is a radiation and what is a electromagnetic radiation, you know from your +2 physics, right? Radiation means energy transfer. We have different modes of energy transfer, right? Conduction, convection, radiation. Conduction means by contact, some physical. Convection means by means of
Excuse me, sir.
Is it audible now?
Yes, sir.
Yes, sir.
So there was a problem in the network. Okay. So this is about the solar radiation. In your physics, you have studied radiation means it will have a wavelength, frequency, all these characteristics. So we can express radiation in terms of either wavelength or frequency. So here they have expressed wavelength in length unit. So wavelength varies over a wide range. You can see angstrom means 10⁻⁸ meter. Nanometer means -9 meter. Micro means -6 meter. Milli means everybody know -3 meter. Kilometer. So usually our visible light, etc. micrometer, we will talk. Micro is not there. 10⁻⁶. Okay. So this you keep it in mind. Wavelength and frequency, and wavelength we will express in for radiation. Electromagnetic spectrum is there. Spectrum means the range of wavelength upon which we will call the different components of radiation. So a solar radiation constitute various wavelengths, radiation. Okay, so we can see objects because our eyes is sensitive to certain wavelength of radiational characteristics. That means out of the total spectrum of energy or radiation available on Earth's surface, we can see objects using this radiation almost from 0.25 micrometer to, or that means 0.3 micron, VIBG or no, 0.3 micrometer to 0.7 micrometer wavelength. So 0.3 means violet, then increases VIBG or indigo, blue, all these things are there, yellow, green, last red, right? Red means almost 0.7 micrometer. So this is a very narrow gap in the entire energy spectrum, right? You can see this blue line is the 0.25 to 0.7. So there are radiation left and right of it. Right of means we have more than red, infrared. So infrared radiation means this, what is the greater than 0.7. The visible light is there. Visible light visible light is 0.3 to 0.7. Infrared you can see from the top. This 0.7 to up to 100 micrometer or 105 micrometer, it will be infrared. So infrared is the main cause for heating of the elements. Okay, due to solar radiation, objects get heated up. No, that is due to infrared. So incoming solar radiation will be high frequency. Once it is heating an object, it will turn to low frequency or high wavelength. So return return radiations from the Earth surface is mostly infrared in nature. That will have less energy compared to incoming. That is why our greenhouse gases can trap it. Okay, it can absorb it quickly and get themselves warmed up and cause all these problems. So apart from visible infrared, we have the ultraviolet. Less than violet means ultraviolet. So it ranges from almost 0.1 micrometer to 100 angstrom. That means 100 into 10 raised to minus 10. So minus 8 meter. So this I think you can get an idea what is the range. So we have the other radiation also, gamma rays, X-rays. X-rays are less than ultraviolet. We use it for taking our X-ray films of bones, etc. That is less wavelength means high frequency radiation. Then microwaves are there. Then radio waves are there, FM, AM, all these things. Long radio waves are there. So this is the range of wavelength for each type of radiation. Okay, where do our mobile radiation comes in this? Any idea? We are nowadays more than radio waves. We use mobile radiation, no, mobile communication. Any idea where it fits? Is it a long radio wave or a short wave?
Yeah, short radio waves.
Short radio waves. You can refer internet. Okay, check it out. They are not given in this one. I also don't know exactly. I give it to as a homework because nowadays we use them very much, right? Mobile tower communication. So next we will go to some terminology. Irradiance, solar power. What is irradiance? Irradiance is the power represented in watt per meter square or kilowatt per meter square. So our ultimate aim is we want energy from sun. So we want to express it. No, everything we can express it in units. If you can't measure it, you cannot control it. Like that a saying is there. So for our modern life, we want to talk about something means we have to express it in some units. So watt per meter square, kilowatt per meter square, like that. So solar constant is the average value of solar radiation outside the Earth's atmosphere, about 1.3. It is about 136 watt per meter. So this solar radiation, as I said yesterday, it is very diffuse and it is very irregular. That means we cannot depend it. It is not a constant energy source, right? Due to sun's rotation, not sun's rotation, Earth revolution over sun and Earth's its own rotation, the availability on Earth is varying, solar radiation. So we can have some values relatively. So a constant means solar constant means what is solar radiation available at outer Earth's atmosphere. So due to atmospheric effect, it will be fluctuating. So extraterrestrial radiation or Earth's outer atmosphere, what is the value of solar? Because between the sun and Earth, there is some vacuum space. No, if you have studied geography, we have Earth, then Earth atmosphere. It constitutes of what is the constituents of atmosphere? Stratosphere, troposphere, ionosphere. So many spheres are there. No. So there are so many gases, particles, etc. will be there. It will affect the availability of solar radiation. So beyond that, there may be vacuum. So at that area, in a particular season or a particular time, the availability is almost constant, right? Irrespective of the geometrical location. Everywhere on the Earth extraterrestrial region, it is constant. That is called solar constant. That is above 1 kilowatt. That is 1366 watt per meter square. So I think you can comprehend this watt per meter square, right? 1366 is 1.36 kilowatt. So 1.36 is almost a electric power consumed by a big motor, electric motor in your home or somewhere, right? That is the energy that per meter square I am telling. So there will be so many meter squares. Total energy will be huge, but per meter square we can expect that much only. So typical peak value is 1000 watt per meter square on a terrestrial surface. So you will see in the next slide, coming to terrestrial surface, that means on Earth surface, it is reducing. Peak value we can expect is 1000, that means 1 kilowatt per meter square. That too on a clear day, facing sun, all conditions are there, right? So per meter square, 1 meter square area. If you take 1 meter square area, you can think what is a 1 meter square? 1 meter into 1 meter. In that area, we can expect at most 1000 watt or 1 kilowatt. Is there any idea how much is the solar radiation in Vellore or in your North India typical value? Anybody? Typical value on a sunny day. It depends on the season, no? So if it is a very sunny day afternoon at outer under the sun, we can expect 750 watts, not 1000 watt. Okay, 750, 800 like that range. If you are measuring inside a tree, under a tree, you can expect 300 watts per meter square like that. So that is the range. Okay. So this 1000 watt is the maximum we can expect under laboratory conditions. So that is why solar panels will be 100 watt peak like that. Watt peak means under peak solar radiation, what is the power output we can expect. So if you check a output rating of a solar panel while buying a panel, it will be rated under STC, standard testing condition. Standard testing condition means under laboratory, if they test with this 100 watt, 1000 watt solar radiation, it will produce this much power output. Actually, it will be less in our operation. And also cell temperature, they will maintain at 25 degree. But in installed station, solar panels temperature will be rise. Okay, because all radiations are impinging on it. So infrared waves will heat up the element. So temperature will not be 25, it will be 40, 45, 50, etc. So it will be again cell efficiency will be reducing. So this we will study in the later units, I am telling now. So this is the solar irradiation. So one thing you understand. Irradiance means power. Radiation means energy. Irradiance. So you can see over the time, if there is no sun, zero solar irradiance, zero power we can get. So at 6 o'clock morning, sun rises, so we will get a little about solar radiation, and then it increases. At noon we can expect high. Then afternoon we will it will come down, and at sunset it will diminish. Right. So there is a peak parabolic curve, solar irradiance. So this peak depends upon locality. It will suppose you are in a very sunny area, you can expect 900 watt per meter square. If you are in a pole area, North Pole, or that area, very little you can expect. If you are in a subtropical country, lesser you can expect. Our India is in a tropical country, we can have more power. So all geographical locations also affect solar radiation. So solar irradiation is there. So first one, irradiance, this power. Then irradiation, energy. What is energy? What is the difference between power and energy? First class we have discussed. What is the difference?
Energy per unit time is power.
Rate of expense or rate of delivery of energy is called power. So irradiance means power. Watt means joule per second. Now per second this much joule we can expect. So per second in a meter square we can expect at maximum 1000 joule or 1 kilojoule. So what is the energy irradiation or solar energy? Solar irradiation sun's radiant energy incident on a surface of unit area expressed in kilowatt hour per meter square, or watt hour per meter square also can be there. Usually kilowatt hour, because electricity, solar radiation, PV means electricity we are getting. What is the electricity unit in your area? In all over, unit of electricity means kilowatt hour. 1 unit of electricity means 1 kilowatt hour. Next time you get a electricity bill, you can check how much units of electricity you consume. Maybe 500 units means 1 unit they may cost 4 rupees, means 500 into 4. How much? 4 into 500, how much?
2000.
2000 rupees you can expect. Okay. Apart from meter charge, some other charges may be there. So 1 unit means 1 kilowatt hour. So typically expressed as an average daily basis for a given month, also referred to as solar insolation or peak sun hour. So this energy means we can different terminology is there. Irradiation is there, then insolation is there, peak sun hour is there. All these things people will be using to express energy, not power. Irradiance means power, radiation means energy, insolation means energy, peak sun hour means energy. So solar irradiation energy is equal to average solar irradiance power multiplied by time. So simple. Power is equal to energy by time. So energy is equal to power into time. Right. Power into multiplied by time. So all these things are not constant. So we will have to take average and all these things. So peak sun hours PSH is the average daily amount of solar radiation received on a surface. PSHs are equivalent to number of hours that the solar radiance, that is power, would be at a peak level of 1 kilowatt per meter. So PSH we will usually tell how much hours, peak solar hour. That means how much hours the sun radiation is available with the peak value. That means 1 kilowatt per meter square. So 1 kilowatt per meter square it will not be there, but still we can express in its equivalence. Okay, suppose solar radiation is there for 10 hours. We can say that effectively solar radiation is there for 3 hours with 1 kilowatt per meter square capacity. So that is the meaning. So the equivalent number of hours per day that the PV array will operate at a peak output levels at a rated temperature. So these are all the thing. So you can see solar irradiance, that is power on the y-axis, time on the x-axis. So it is varying like this. So energy means power into time. So it will be the area under the graph. Solar irradiation. Energy is the area under the solar irradiance power curve. So any diagram, area under the curve is the product, no? X into Y. So power into time, area, energy. Peak sun hour we can talk like this. Again, irradiance, solar irradiance, power curve is there, blue one. Into time means we will get energy. That energy we can express as a square. Suppose peak power is 1000 watt per meter square. It may be theoretically at noon only, but we can express it is available maybe 3 hours. So from 11 a.m. to 3 p.m. we can get at so this other areas are 0, but we have got a square solar installation, that is called solar installation, peak sun hour, right? So suppose we have the solar panel installed, our equipments are 3 kilowatt equipments, so we can roughly tell solar installation is 2 hours means 2 into 1000 watt per meter square, right? 2 kilowatt. 2 kilowatt hour of energy we can expect. So how much hours our 3 kilowatt item will work? Less than 1 hour, right? We have 2 kilowatt hour energy. Energy means kilowatt into number of hours available. 2 kilowatt hour. Our item power consumption is 3 kilowatt. So 2 by 3 hours, less than 1 hour, we can operate that machine. That is the meaning. So this we will talk more later. Then solar power and energy example. Simple calculation I will tell to give you more information. So solar power incident on a surface averages 4000 watt per meter square. So 400, not 4000 per meter square for 12 hours. How much solar energy is received? So it is very simple. Power irradiance is given, watt per meter square. Power, that is given. So energy means into time. For 12 hours it is getting at 400 watt per meter square. So energy means 400 watt per meter square into 12 hours. 4800 watt hour per meter square. 4.8 kilowatt hour per meter. In other words, 4.8 peak solar hour, right? One solar hour, peak solar hour is equal to at 1000 watt per meter square or 1 kilowatt per meter square, how much hours it is getting. So 4.8 kilowatt hour meter square means at 1000 or 1 kilowatt hour, 4.8 hours it is getting. So 4.8 PS peak solar hour. Next question, amount of solar energy collected on a surface over 8 hours is 4 kilowatt hour. Energy means kilowatt hour per meter. What is the average power? So energy is given. What is power? What is the relation? Energy power by time is power is equal to energy by time. So power, we have power 4.8 watt per meter kilowatt hour per meter square by 8 hours. 0.5 kilowatt per meter square. 500 watt per meter. So power is equal. Average power is equal to 500 watt per meter square. So this is the same formula, different question. Okay, PV system produces 6 kilowatt AC output at a peak sun and average operating temperature. How much energy is produced from this system per day if the solar energy received on the array average? So 6 kilowatt is produced. 4 hours means 27 kilowatt hour per day. Then atmospheric effect. I told 1300 watt per meter square is getting over extraterrestrially, but at this earth surface we can expect a maximum 1000. Why it is? Due to atmospheric effect, right? Approximately 30% of extraterrestrial solar power is absorbed or reflected by atmosphere. So 30% of the 136 is right. That means how much? Nobody is good at maths. What is the extraterrestrial radiation value?
$409.8.
How much? 1366. Okay, 1366 into 30%. 1366 into 0.3. 4098. Okay, 409.8. That is 409.8 watt per meter square is absorbed. So we can get 0.7. On Earth, we can express 0.7, 9556 watt per meter square. So out of 136 is 30% is as absorbed means almost 1000. That means 956 means almost 1000. Okay, that is what on Earth surface we can expect 1000 watt per meter square. Okay, practically it will not be there. We can expect 750, 800 like that. So maximum 1000 we can expect because atmospheric effect is there. Atmosphere, there will be absorption, reflection, scattering, so many other phenomena. Okay. So effects vary significantly with altitude. So this all depends upon where we are. That means altitude, latitude, time of the day, year, air pollutants. So clear sky means if pollution is not there. In India, etc., pollution is very high. Our sky is not clear, but other some clean countries you go, sky will be clear and you can expect more radiation. Weather pattern, wavelength, direct beam radiation. So there is components of radiation. Direct beam or normal radiation is the component of the total solar radiation incident on a surface normal to the sun's rays that travels in parallel lines directly from. So this is clear, no? Direct solar radiation is, we can talk it into components, direct and diffuse. So total radiation is equal to direct radiation plus beam radiation. Sorry, direct radiation plus diffuse radiation. So direct is also called beam or normal. Diffuse is the diffuse itself. Total is also called global radiation. Total radiation means global radiation. So this is, I will make you more clear. If you are directly under sun, you will get mostly beam radiation because direct solar radiation you will come and hit you, right? Because there we can draw a line between you and the sun because you are you can visible you can see sun directly. You can see sun directly means there can be a direct line between you and sun, and the radiation can travel over it, right? So if you are right now under a sun means you can receive solar radiation. Not under a sun, there if you are at least seeing the sun directly. So I don't think you are outside now. You are inside a house and listening to me, right? So this is the radiation you are experiencing is diffuse radiation. What is a diffuse radiation? Component of the total global radiation incident on a surface that is scattered or reflected. So there is no sun that is visible to you from your house, right? Inside your house. So, but still there is light. Without your electric light, you can see object because how this is due to diffuse radiation. Radiation coming from your window. Window is not a radiation producer, right? Where do window get light? Light is getting emitted from the outside your house. Where the outside house get radiation? From the matter that reflects solar radiation. So there may be another building that will reflect the solar radiation incident in on it. There will be objects, there will be earth, ground itself reflecting back. So many sources can be there. There will be there will be component that is reflected from the clouds. Okay, not directly from the sun, but reflected from the clouds. So all these constitute diffuse radiation. So mainly ground reflection albedo is there. Okay, ground reflections component is called albedo. So this is the two types of radiation. So total radiation on Earth's surface can be typically 700 to 900 watt per meter square in a sunny day, out of which, that is total radiation, out of which maybe 70 to 80 percentage this direct, 30 percentage diffuse, if we are measuring it outside, right? If it is inside, means majority almost thing will be diffuse only. So you can expect some 300 to 400 watt per meter square in a clear time. Okay, noon time, etc. So this is the fact that we have discussed in the previous slide. Sun is there, Earth surface is there. Earth surface is this black horizontal line. So solar radiation coming to extraterrestrial region, that is that black horizontal dotted line up, that is limit of atmosphere. Limit of atmosphere means starting of extraterrestrial region. At that area we can expect 1366 watt per meter square. Now what is happening? Atmospheric absorption, scattering and reflection. So we have atmosphere, many particles, gases, water vapor, pollutants, all these things. They will absorb it, reflect it, scatter it, all these things they will do. We have cloud, that also will do all these things. And apart from that, we have gases, greenhouse gases, that will also absorb. So, and that is the problem that we have discussed, global warming. Today also I read an article by NASA towards the end of the century. What is happening? Major cities in the globe. So in India, major cities, port cities, Mumbai, Kolkata, Chennai, Cochin, all these things will be underwater. Not too late, and by the end of this century means some 50, 60 years. Okay. So that is the effect of global warming that we are experiencing. So we have to consider when we pollute atmosphere, this phenomena is there, absorption. Solar radiation will come do a job. No, it will be absorbed and average temperature of Earth is going to be increased. So what the people are trying to focus now. Have you heard of COP? Anybody? What is the meaning COP? Confederation of Parties. Some summits were there to discuss about the global warming issues. It started 80s, 90s, etc. And some Kyoto Protocol, these things. After that, every some duration of years, this meeting will be there to review the progress to have a sustainable energy use. So people have discussed the ways to limit the temperature increase by 1.5 degrees Celsius. Already the increase of temperature is witnessing. So we can allow from now 1.5 increase temperature. If we go beyond 1.5 degree, it will lead to catastrophic effect. So our greenhouse gas dependence should be reduced. So countries are framing policies, but it is not in a good direction because we cannot use all renewable energy. Fossil fuels are being continuing used, so global warming effects are more severe, and some countries withdrew from the treaty or the agreement, like USA, due to various political and economic reasons. So all these things are happening. So you can discuss more about this one later. So this is the things of solar radiation. Okay. Air mass. There is a concept called air mass. Have you heard about air mass? Yes or no?
No, no, sir.
So we have sun, we have earth atmosphere. Earth is this green one. Its encircle is the atmosphere. So air mass means the distance usually between the sun and earth. So by picture you can see zenith means when the sun is over your head. That is a zenith position. At noon you can expect sun zenith. So there will be a distance between sun and earth, right? So that is called air mass 1. So outer atmosphere the distance is air mass am0. Then the distance between outer atmosphere and the earth surface is called am1, air mass 1. By default people have defined like that. So if the sun is at evening, it will move from overhead to some other position, right? So sun at mid morning or mid afternoon, that means 3 p.m. Mid afternoon means 3 p.m. Mid morning means 9 a.m. At that time you can expect not over your head. You can expect at some angle. That is called zenith angle. Theta z 48.2 degree. You can expect. So at that time there will be a distance between sun and earth surface and also sun and outer atmosphere. So the distance between sun outer that outer atmosphere and the point you are standing is called am 1.5. That means that because it is am 1 then divided there is an angle, no? So that distance increased. So 1 by tan 45 something 48, that is 1.5, that is increased, you can calculate. So am 1.5. So this air mass is that measure of distance of the sun related to you at various time. This is not relevant for your calculation now, just I am telling. There are some equations. P by p0 1 by cos theta z. Theta z is the zenith angle, p is the local pressure, P0 sea level pressure, all these things. So we will go to next slide, measuring zenith angle. That is not needed now. US solar radiation. We are more interested in India solar radiation. You can get radiation data from MNRE website, or there is institute called the National Solar Energy Institute, NICE, in India. They are also conducting solar training program online. If you are interested, you can join. Online program on solar PV, all these things are there. You can visit the NES website. Spectral irradiance. What is spectral irradiance? Irradiance means power, right? We have already seen. Spectral means at a different wavelength, what is energy? Spectral irradiance, watt per meter square per micrometer, per wavelength, micrometer. So this is wavelength per micrometer. So more energy, more power is at a less wavelength or high frequency, right? So E is equal to h nu. If the wavelength is less, frequency is high, energy is high. H is Planck's constant, right? So absorbed by water, all these things are there. So this is a typical spectral solar irradiance data. So AM0 means extraterrestrial, AM 1.5 means terrestrial total global, terrestrial direct means AM1. So these things are there. Different components you can refer. Solar radiation measurement. Next we will talk about how to measure solar radiation. So we can roughly talk about in Earth surface we can expect 9,000. Sorry, 9,000 not is there. 900. Okay. Always we can think about solar power less than 1,000. So 900 watt per meter square, 800 watt per meter square, etc. But actually how much it? We want to measure it, right? So some devices are there. So a pyrometer measures total global radiation, or so not radiation, irradiance. Radiation means energy. Total solar irradiance, solar power. Measurement over time are integrated to calculate. So we can get instantaneous values. If we want that energy, we have to multiply with the time. Irradiance measurements are used in the field to translate actual output of. So this measuring is very important in industry for estimating the project report of solar power. Okay, if some companies are solar PV business, they want this data. So this is precision spectral pyranometer, PSP. So pyranometer measures broad global solar radiation, broadband, direct and diffuse. So it simply measures global solar radiation. That means global means direct and diffuse. So it will have a sensing area under a glass cover. So you can see a glass cover is there, double layer glass cover. Up it will, if we place it on a sunny surface, all the radiation will come and hit in the glass cover, right? It will be exposed to sun directly, so direct solar radiation will come and hit, and some diffuse item from the side also come and hit. It is the sensing area will be at the visibility of the radiation, or diffuse plus direct. That means it will have a under this glass in the vicinity itself there will be a black surface. What is this black surface? Thermopile. What is a thermopile? Anybody? Thermocouple, have you heard of?
No, sir.
You don't have heard of thermocouple? Nobody. Thermocouple is a subject matter in physics +2. Jatin, Siddhartha, Sony.
Yes, sir.
What is a thermocouple?
It's some device, sir, thermoelectric device for measuring temperature.
So what is a thermoelectric device?
Sir,
What do you mean by thermoelectric device?
it is used for measuring temperature between wires.
Temperature between wires. How it is made of? Thermocouple, anybody? You can nowadays buy some cooling elements from Amazon, Flipkart, etc. If you connect it to a battery, one side it will produce very cool with a aluminium zinc, etc. Have you noticed? It is a thermoelectric cooler. So it will constitute thermocouples. Thermocouple means two dissimilar wires coupled. You take aluminium and copper, two pieces. You make a loop by joining these two ends. It is a thermocouple. Right. So what is the property of thermocouple? There is Peltier effect and Seebeck effect, right? Can anybody define these effects? Peltier effect means Elena Parajuli.
Yes, sir.
Can you define Peltier effect?
So I think Peltier effect is absorption or emission of heat because of flow of electrons.
Okay, okay. And what about Seebeck effect?
So in that we put the two ends of the thermocouple at two different temperatures, then electron will flow in certain direction based on the thermocouple series.
Yes, yes, yes. Very good. That means there is a direct connection between heat and electricity in a thermocouple. So thermocouple means a joint, a loop made of two dissimilar metals. Okay, it need not be copper, aluminum always. Any metal you take, make a loop. So if you can place two temperatures at two junctions, there will be two junctions. No, if you make a loop. If you keep one junction at ambient, another at 100 degrees Celsius, you can measure a flow of current in the, or you can at least measure a potential difference between two ends, right? So that is due to property of this material property. Different metals means different electronic structure. So electronic structure again depends upon its temperature, all these things. So some potential difference is created. It was discovered, I think, by Seebeck, scientist name, and Seebeck effect we are talking. The opposite also possible. If you make a potential difference between these two junctions, we can expect different temperatures arising. So you make a thermocouple, make a battery connection between two junctions. You can expect one junction at a lower temperature compared to other. That is what we are using in a thermoelectric cooler. You can buy it online. Okay, small cooling. You cannot use it as a big cooling element like a refrigerator, but a small sports cooling. If athletes may use it. If they got a sport injury, they can apply it on that place. Okay. So that means apply battery current, you can expect temperature difference. That means cooling. It will absorb from one heat from one end and reject in the other end. So here we can apply the same thing. The sensing element will be there under this glass cover. So we are making solar radiation to impinge on it means that area, sensing area will get heated up, right? So the other end of the junction we will keep inside the body, that will not receive solar radiation. So that will be at ambient temperature or normal temperature. Whatever getting heated, that is exposed to solar radiation, and that is why it is getting heated up. So we are actually producing a two temperature at respective junctions of a thermocouple. So there will obviously be a what is called a potential difference or electric potential generated that we can calibrate to give the measure of solar radiation, right? Is it clear? So how much potential is generated? It depends upon temperature. So temperature again depends upon amount of solar radiation receiving. So direct plus beam, totally it will receive in this configuration. That is called a pyranometer. So that will give you the amount in terms of millivolt, small voltage we can expect. So that small voltage we can calibrate to give watt per meter square power of the radiation. So if there is no light, there is no voltage, 0 watt per meter square. If there is little light, little voltage is generated. So little power we can get. In the noon, there is more light and more diffuse radiation. Diffuse, I think you know what is more total global radiation means more direct radiation. That is, sun will be there directly, it will come and hit the sensing area under the glass. Diffuse means towards all the 360-degree surrounding the reflected scattered all radiations will come and hit, right? So it will give total global radiation. So that will heat up the top
Excuse me, sir.
area. Another class, right?
Yes, sir.
Yes, sir.
So you review all these things. That is pyranometer, total global radiation. Another one is pyrheliometer. Beam radiation alone we can measure. Okay, so the sensing area will be underneath the tube. So only beam radiation directly from the sun. So we can align this instrument tube directly for facing the sun, and we can measure that. Same principle of operation. Okay. So this is the measuring items. We will continue next class. So I have put the question in the VTop. Okay, all of you do it. The question is about a case study about a solar PV application. So you can, if you are in a place, you can directly visit the PV. You can visit and take. Otherwise, you can take a case study from internet also. I don't insist you to roam around in this COVID time to get the details. Better you go and take if you are in an accessible place. But if you don't find it hard, means you can study available literature in the internet and get a report.
Sir, we can
Yes,
call
sir.
and ask, no, sir, if you want.
Call and ask is today one student asked me, he was there, but he was not given the details. So either internet search or other things you can use. Okay, if otherwise you can directly observe how much number of panels, what is the rating of panel. It will be written underneath the panel. Just you can calculate all these things. Only thing is I want you to get into an actual PV application. There are so many applications. Today I saw a vlog, a boat made of flexible solar panels. So it will be charged by solar PV mostly. If there is no, it will be externally charged from the grid. So 3 kilowatt motor is there. It can run over for 3 or 4 hours. So it is not polluting and making sound in the river, right? So a tourist place, very eco-friendly boat. So like that, any application innovative. It need not be for a rooftop or big solar power project. Small items also you can expect or you can write.
Yes, sir. Thank you, sir.
Okay,
We'll do
thank
it.
you. I will wind up. Okay, today we will wind up. Thank you.
Yes, sir. Thank you.
Sir,
Uh,
sir, I have sent you photo regarding the. I have clicked on solar.
yeah.
Sir, that the necessary information, like there is a maximum power rating and all of that information on that panel.
You can use that per panel information. Then you can estimate how much is the total. You can just count how much panels they have installed. Like that you
Okay.
can proceed. And what is the use? How much energy they can expect? All these things you can write. For what that energy is used.
Sir, if
So
sir, that solar plant is 1 megawatt plant. So
hmm,
1 megawatt is generated in 1 month or in 1 day? I have this question.
no, megawatt is the capacity, power capacity. So per second, 1 megajoule. That means 1 into 10 raised to 6 joules it can produce. How much energy produced means how much time it is exposed to solar radiation. So 1 megawatt plant exposed 1 second means it will produce 1 megajoule. So 1 hour means into 60 into
O-
60 like that. 60 into
So
60
means
means.
yes.
Uh,
So
so
means one
average only,
one
it will be
megawatt.
rated at a peak power, but always we cannot expect 1 megawatt. No, if, solar radiation is fluctuating. So average value we have to take per day. How much PSH, peak solar hour, we can get, like that you can calculate.
Okay, sir.
Okay.
Okay.
Okay, then you can leave. Any other doubt? So you try to complete it in 1, 2, 3, 4 days, and before 15th you can upload. Today is 10th,
Sir,
no?
I can also use study, right?
If you find it difficult to get practical information, means you can get a case study. Internet,
Okay,
so many resources are there. Okay.
okay, sir.
Okay. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.